So let's now try out our first decision tree. First of all, we need another data set. We can use the same data set as previously, Wisconsin Diagnostic Breast Cancer data set. We go to the icon model. We pick a decision tree. We combine our data set with tree, and we pick the visualizer for a tree, so that's tree viewer. We combine tree with tree viewer. If you double click on tree viewer, you can see, for example, different trees. If you change this, for example, to 2 levels, that's a very simple decision tree with just one test. That's, for example, worst radius. That is one feature, and if that is smaller or equal 16.77, so that's the feature of the tumor. If that size is smaller, the worst radius, than 16.77, then we go into the left part of that tree, and then we have quite a good split. Just by that simple split, then we have 346 instances out of 379 which are benign, so that's 99.3%. On the right hand side, if we do the same test, we have 94.2%, 179 instances out of 190 are malignant. So just that simple split achieved quite pure lymph nodes here. If you develop a further decision tree, for example, by one more level, you can further break this down into another feature, worst concave points, to achieve even more pure terminal lymph nodes. So how did we do this? In this course, we talked a lot about the Gini index and the entropy. Gini index or entropy can be used to verify and to assess how pure such a test is. So that here, for example, would achieve quite a pure test. So entropy would be quite low, as well as Gini index. The same would apply here, because that is also quite pure, 94%. And if you look further down, so if you apply another test for another feature, that is almost 100% here, so that would be quite a very low Gini index or entropy. You can also develop this up to more levels, say 6 levels, and here we have a 100% case. So if you follow down this test from the root down to here, 10 out of 10 cases are benign, and we would have an entropy of 0 or Gini index of 0. The same applies to this one and to this one. One of the downside is, obviously, if you take too many levels, you lose the ability for interpretation and generalization, and it might be better to operate with a smaller data decision tree, which can be better used for interpretation, for clinical interpretation, and as well as to assess unseen features based on this decision criteria.